The question says that the image of a small electric bulb fixed on a wall of a room is to be obtained on the opposite wall 3 meters away by the means of large convex lens. What is the maximum possible focal length of the lens required for the purpose? Now, in this diagram, we see there is a electric bulb on a wall and there is a convex lens which will be used to cast an image of this bulb on that screen or the wall. And the distance between this wall that is carrying the bulb and the screen is 3 meters. Now this distance is fixed. We have to find out what would be the maximum focal length for which we can cast the image on that screen. So here we will use the lens equation. So for maximum focal length, we will solve for f maximum. Now we have assumed u to be x variable, that is distance of the object or the bulb or the wall that is carrying the bulb from the lens as u equal to x. Now obviously the image distance will be 3 minus x because it is fixed. The distance between those two walls is fixed. Now using the sign convention and the lens formula and substituting the values in this equation, we will see that 1 by v becomes 3 minus x, and since v, the screen is on the right hand side, it is going to be positive, so it would be 3 minus x, minus u is on the left side of this lens, so it is going to be negative. So I have substituted 1 by minus x equals to 1 by f. So using the values u equals to x and v equals to 3 minus x, we have substituted the values over here in this lens equation. Now solving for f, we get the value of f as 3x times 3 minus x by 3. Now upon simplification, we will get f as x minus x square by 3. Now for fx to be maximum, for this focal length function to be maximum, we know the mathematical condition, that is this one, f dash x, or the differentiation of the function of focal length with respect to x must be equal to 0, and the double differentiation of that function with respect to x must be less than 0. Now differentiating it for the first time with respect to x and equating it with 0, we came to the conclusion that the value of x is 3 by 2 or 1.5 meter. Now checking it for the double differentiation, we get the negative, that is for the value of x as 3 by 2, fx is going to be negative, fx is going to be minimum. Now since we know that we have used as 3 minus x and we have got the value of x, that is u, so we have got the value of u and v as u equals to 1.5 meter and v as well as 1.5 meter. Now using those values in the lens equation with proper sign convention, we come to the conclusion that 1 by f is equals to 1 by 1.5 minus of 1 by 1.5. Now upon calculation, we will get the value of focal length as 75 centimeter. Thank you.